I am Dr. W. Binuclear from Kamla Nehru Mahavidyalaya, Nagpur. Today we are discussing the metal cluster, and in which binuclear and trinuclear metal clusters we are discussing in today's part. And as we know, there is a quadruple bond in the structure. We have seen in case of Re2Cl2- oxidation state of rhenium is +2. Now today we are discussing bimolecular metal cluster, in which the MO2Cl3- in which the molybdenum have +3 oxidation state. So both the compounds have the similar structure, only there is a difference in the oxidation state. So in today's part we are discussing the binuclear molybdenum metal clusters and also trinuclear metal clusters. So today's topic is metal cluster, and in this we are discussing the metal-metal bond in binuclear and trinuclear metal clusters. So in today's part we are discussing two important compounds. One is a binuclear compounds and second is trinuclear compounds and their examples. So as we have discussed the binuclear metal cluster of taking the example of Re2Cl2-, in which the rhenium have +2 oxidation state, and similarly another example of the binuclear metal cluster is the which contain the metal-metal bonds is the MO2Cl8-3-, and in this case the structure of this MO2Cl8-3- is having the identical structure similar to the Re2Cl8-2-. Only the difference is there of the oxidation state. In Re2Cl8 rhenium have +2 oxidation state. In case of MO2Cl8-3- the oxidation state is +3. So only the difference is there in the oxidation state of the metal, and in this case there is also metal-metal bond. So in case of binuclear metal complexes having the metal-metal bond, and structure of this here is shown of molybdenum and rhenium. So this is the structure of rhenium, and this is the molybdenum diacetate and halide. So here this is the dimer of the rhenium. So one rhenium attached with the 2 acetate group and one halogen, another rhenium having one halogen, 2 acetate group, and the these other. So this is the rhenium acetate diacetate halide, and so in this way the structure of this rhenium compound is shown. So structure of Re2CS that is the ReCH3CO twice X2 is the compound rhenium acetate diacetate halide, and similarly here in this case of molybdenum there is no halogen, only the diacetate dimer of this compound is shown here. And so first structure is the structure of ReCH3CO twice X2, this is one, and dimer is shown in the structure. Another structure is similar structure is there of molybdenum diacetate, no halogens are there. So this is the one compound MO, and this 2 acetate group, this MO with 2 acetate group, only the halogens are there in case of first of rhenium. So this both the compound rhenium and molybdenum have identical structure. So in both the structure metal-metal bond is there and has quadruple bond. So in this both the case there is a quadruple bond, rhenium 3+ and molybdenum 2+ has D4 configuration. Both the complexes are eclipse configuration. So it is shown that both these structures have eclipse configuration, and another structure is shown here of the metal chromium and copper, and structure of this compound is of the chromium and copper is shown in this slide. And in this case, so in case of this chromium diacetate aqua water is there, the chromium bond order is uncertain, while in case of copper, the copper has a single bond. This is due to the benign configuration of copper. The single bond between two copper is confirmed on the basis of bond length. So there is a metal carbonyl clusters. So such cluster contain metal atom in the valence state, -1 to +1 oxidation state of valence state, and have carbonyl group to stabilize the low oxidation state. They have long metal-metal bond. The clusters are formed by the transition metal which are placed on the right hand side of the periodic table. For example, iron, cobalt, nickel are the examples. High, and in this case the clusters are formed by the transition metal and metal carbonyl clusters divided into two groups: low nuclearity carbonyl cluster and second is high nuclearity carbonyl cluster. But now here the structure is shown of the copper and chromium, in which the structure is similar to that molybdenum and rhenium. So here are the two metals, two acetate groups are here, two aqua waters are here. So again this is the dimer of the here M for the metal and copper or chromium. So this structure is identical with the molybdenum diacetate structure, which is we have seen previously. In both these metal-metal quadruple bond is present, and in this case chromium complex, in case of chromium complex, the chromium bond order is uncertain, while in case of complex of copper there is a copper single bond, and this is due to vinyl configuration. So this is the structure similar to molybdenum or rhenium also. And so these are the examples: Re2Cl8, MO2Cl8 3-, and these are copper and chromium complex are the examples of binuclear metal clusters, also known as the complexes. And important condition to form the metal-metal bond is that number one condition is that metal should be in a low oxidation state, and second, the stability of the valence shell configuration of the metal. So these two are the important conditions. Now in case of trinuclear metal cluster, in trinuclear metal cluster means in which the three metal atoms are present. So best known example of this trinuclear metal cluster is the rhenium trihalide, that is Re3Cl9, and their derivatives are there which is having similar metal cluster trinuclear. So Re3Cl9 is a dark red colored cluster having the structure shown in this slide. Re3Cl9, this is the structure. 3 rhenium are having a triangular shape, and this rhenium have 1, 2 terminal, and these are the bridge Cl between these two. This is one bridge, this is Cl, another bridge Cl between these two rhenium, another Cl which is bridge between the two rhenium, and this is one terminal, this is another 2 terminal, and here 1 and 2. So each rhenium have 2 terminal, one above and below the plane, and in this way the bond length is also shown here. Here is a double bond, one is a sigma and one pi between the rhenium. So structure of this compound Re3Cl9, so total are there. So this is the 3 Cl rhenium, and 3 are here in bridging, and 6 are there on each. So 6 and 3, 9. So structure is Re3Cl9 of this metal cluster is shown, in which the metal-metal bond is present. So in this case of trinuclear, it has 3 rhenium metal in triangular planar arrangement. Rhenium are joined by the double bond, and presence of double bond is confirmed on the basis of bond length, and that is the 249 picometer centimeter here, and which is smaller than the metallic rhenium and larger than Re2Cl8. So Re3Cl9 cluster is diamagnetic in nature, which also confirm double bond and 2 rhenium atoms. If there is a single bond between the 2 rhenium, then clusters should be paramagnetic. So it depends upon the structure, and the rhenium atom are also joined by bridging Cl ligand, which are shown in this slide. 3 rhenium atoms and 3 bridging Cl are in one plane and forming hexagonal network beside the bridging Cl. Each rhenium has 2 terminal Cl ligand. One Cl is above and other Cl is below the plane. The structure of Re3Cl9 and Re3Br9 is identical, but the structure of Re3I9 is different, which is thermally less stable and therefore has infinite chain of trimeric unit rather than planar network. So it is shown here, that is the in case of the structure of Re3Cl9, Re3Br9 are having the identical structure, but Re3I9 is different because it is thermally less stable. So the Re3Cl9 unit joined with other Re3Cl9 unit in which one of the terminal Cl ligand act as a bridge between the two Re3Cl9 unit. So here the structure of this compound is shown here, that is Re3Cl9 is shown here. Re3Cl9 unit joined with each other, and Re3Cl9 unit in which the terminal Cl ligand act as a bridge between the two Re3Cl9 unit. So this is the important compound, and here is shown the how it is prepared. So Re3Cl12 now, Re3Cl12 cluster compound can be obtained. The reaction is shown here. We have seen that Re3Cl9, now Re3Cl12 3 minus is the another cluster of rhenium, and it is obtained as shown here, 2 rhenium plus 5 Cl2 forming twice ReCl5. This compound is obtained. In second step, ReCl5 we have taken, it decomposed and forming ReCl3 and Cl2 get evolved. In third step, ReCl3 taken here, react with the cesium chloride and forming cesium ReCl4. So in this way, cesium ReCl4 addition compound is formed. This compound in the fourth step we have to take 3 molecules, and when we heat, it forms CS3 Re3Cl12. So this is the compound in which this is the unit Re3Cl12 3 minus. So this is the name of this compound is dodecahalotrirenate 3. So the cesium of 3 here 1 plus and 3 are there 3 plus, and here having the 3 minus. So this is the Re3Cl12 3 minus rhenate compound, and in this way Re3Cl12 3 minus cluster can be obtained in these 4 steps. So the structure of this unit is shown here, Re3Cl12. So in this case, see 3 rheniums are there, 1, 2, 3, and 3, and these 3 terminal 9, and these 3 12. So Re3Cl12 3 minus cluster structure is shown here, in which this metal bond is having double bond, here also double, and also here 247 is the bond length. So this is the structure of this Re3Cl12 3 minus. So trinuclear metal cluster. So the structure is shown here, and another example, that is CS-ReCl4 does not have tetrahedral type structure, but combined to give trimeric structure, that is Re3Cl12 3 minus. So here a CS-ReCl4 is the compound there. So this compound does not have the tetrahedral type structure, but combined to give trimeric structure of Re3Cl12 3 minus. In Re3Cl12 3 minus, additional Cl ligands have coordinated to empty positions present in the Re3Cl9 unit. So in this way the compound is formed, and in that case rhenium bond distance is 247 picometer, and rhenium distance in this cluster may vary from 240 to 250 picometer. It depends on the ligand which coordinate with the rhenium in cluster instead of Cl. So this is the one example, important example of trinuclear metal cluster, that is the rhenium compound. So here that is the structure is shown. Some more structures of trinuclear metal clusters are shown here. Re3Cl12, Re3Cl9 are the example of trinuclear metal cluster. This is the ruthenium metal cluster. 3 rutheniums are here shown, and this ruthenium have 1, 2, 3, 4. This ruthenium have 1, 2, 3. This ruthenium have 1, 2, 3, and this is the 4 are there. So each having 4. So this lithium have 4, this lithium also have 4, 1, 2, 3, and this is 4. This have 1, 2, 3, 4. So each lithium have 4 carbonyl ligand and forming this type of trinuclear metal cluster. In case of carbonyl, trinuclear, triluthium, that is Ru3Cl12 is the structure of trinuclear metal cluster. Another example is shown here, that is Fe3Cl12. This is the carbonyl in a cluster. Fe3, 1, 2, 3 are the Fe, and each having 4 again the carbonyl groups, which are shown here in this way. Here Fe having 1, 2, 3, 4. In the similar way, this Fe and this Fe also have 4. So this is the another structure of carbonyl compound showing trinuclear metal cluster. So today, in today's part, we have discussed the important metal cluster, particularly the trinuclear and binuclear metal cluster. In case of binuclear metal cluster, Re2Cl82 minus, this compound have structure and in which the metal quadruple bond is present. In case of quadruple bond, one is a sigma, 2 are the pi bond, and one is a delta bond. So one quadruple bond is present, and MO2Cl83 minus also have identical structure, only they differ in the oxidation state in case of binuclear. And in case of trinuclear, we have seen the Re3Cl9, Re3Cl12 metal cluster and their structures, and also some carbonyl metal clusters also show shows the structure and in which different structures they have. And so in case of cluster, so binuclear and trinuclear, so 3 metal atoms are present, 2 metal atoms are present, and their examples we have discussed in the today's part.